and welcome to a new video. In this video, we're going to keep talking about C++, and today we're going to talk about classes and objects. We're going to see what are classes and why do we need classes, what our objects are, and we're going to talk about object-oriented programming. We're going to see the syntax of creating those classes and objects. We're going to understand the concept of encapsulation. We're going to see the difference between public and private keywords. We're going to talk about constructors, destructors, and overloading for constructors. So let's start with, before I say anything about classes, let's just have an example here. And this example could help us a little bit understanding some of the benefits of why do we need classes. So let's start with this. Imagine that we want to create an application for students in college. So what I'm going to do, I'm going to assume that the student will have a full name, and let's assign that to Adam Smith. Semicolon here, and let's push this back, lowercase s. And another thing that a student will have an ID number, so I'll put an integer. I'll say student ID, and I'll assign that to 112, something like that. That's how simple it is. Now, let's imagine that I want to print those information for that student. So I could come here and say void print stu, and we're going to have to pass the student full name, so string fn for the full name, and then ID, integer ID, and then all I have to do is cout fn, and then let's put a space here, and I'll put an ID and line. And again, just think about this. This is a very, very simple application here. If I'm going to print the information, so I'll go print stu, and I'll pass with the full name and the student ID, and put semicolon here. Now let's just make sure that everything works with no problems. Of course it should. I don't see any reasons why it would not, but again, we know here it is, Adam Smith 1112. Okay, now let's talk about this example here. One thing you should know, if you're going to create an application for a real life college where student information are stored, you should know that you don't have only a full name and student ID. Well, basically you have his address, you have his financial situation, you will have let's say payment method, you will have courses that he's taking, you have information about the instructors that are teaching that students, and you have a really long list of variables to define that student. Now add to that, when we talk about methods, functions for that student, here I just have one function, which is print. Well, we can have a function to enroll him in class, we can have functions to drop him from a class, we have a function to print the classes that he took, we can have functions to search for classes, and we can have a really long list of functions that we can actually use for that student. Now, put that on the side and think about this. All I'm saying here is apply to one student. What if I have two? Well, then I have to duplicate all that. What if I have five? Then I have to have a full name, student ID, and all the long list of operations for each one of the students. And basically, this will be a really, really long application. This is where class comes handy, and it helps a lot. What are we going to do in classes? Basically, we are going to define a new data type, I'll just put it that way, a new data type, and we're going to call it student. We're going to put all these attributes and those variables and those functions under one unit, and we're going to call that unit a student. And that's basically what a class is. It's basically a combination between variables and methods, and usually it doesn't happen like randomly. Basically what we do, when you create a class about something, all the attributes and methods need to be related to that thing that you're trying to create. So if I'm creating a class about student, then all the variables are going to be used to describe student, and all the methods or all the functions that we're going to use basically are going to be used for that student. And by the way, in classes, we call functions methods. Okay, so that's basically what classes is. Now let me just go back here to one thing so I don't forget. Encapsulation is basically the process of combining all these elements under one unit. And that's basically what I mean by encapsulation. So let's go back to our example here. If I want to create a class, how do I create a class? And then after that, we have to understand what is an object. So before I go to the process of creating those classes and objects, let's talk about classes. Let's talk about objects, and let's talk about object-oriented programming, and then we're going to move on to the syntax. So we have the idea now. It makes more sense to put all these elements, variables, and methods defined under one unit, and we call a student. You can create a class called cars. You can create a class called houses. You can create a class called treadmill. You can create a class called a computer. You can create a class about anything. And that's the beauty of this concept. Now, the class by itself presents what we call a blueprint. And the blueprint is basically the design stage. Like, for example, if you want to create or manufacture a car, the engineers basically will sit in a big table and they will have that blue map where they're going to describe everything about that car. And then they took the blueprint to the manufacturer to start making cars out of it. Classes basically represent that blueprint. It's where you sit and you design. You're going to think about, what am I supposed to do here? How many variables? What is the variables that I'm going to create? And what is the methods and functions I'm going to create for that class? And that's basically what a class is. Now, right after you're done creating the class, you can, after that, create objects out of that class. And there's no limitations of the number of objects you can create. Like, for example, I can define a class called student, and from that student, I could create 20 or 40 or 50 or 100, 1,000 of different students. Each one of those students will have a full name, but each one of them has a different full name. And that's the beauty of classes. Each student will have an ID number, but again, each ID number is unique. It's different than the others. And that's how basically it works. So we know now that we type classes to create objects out of them. The same way when you design a car, you have that blueprint, and from that blueprint you actually use it to manufacture those cars, which are going to be considered as objects. So what is object-oriented programming then? Well, object-oriented programming, it's a different style of programming, which is basically built based on classes. What does that mean? So far, whenever you have any problem that you studied in those last 4 or 5 videos, you think about any problem as a sequence of steps. Step number 1, step number 2, step number 3, and 4, and 5, and 6. With object-oriented programming, we put that on the side. We don't think about the problem as steps. We think about the problem as multiple objects interact with each other. And that's the key here for object-oriented programming. Just like when you get inside a classroom, what do? You look around, all you see are objects. The desk you're going to see sitting on is an object. The computer you're going to be using is an object. The chair, the instructor in front of you, the projector, the walls, the furniture, everything is an object. And all these objects work together to get something done, which basically you getting educated. So that's the concept of object-oriented programming. What do basically? You think about any problem as a group of objects interact with each other. So in the future, not in this class, in this video, in those courses, but in the future classes that you may be interested in, whenever you have a problem you try to solve using object-oriented programming classes, the first thing you're going to think about, okay, how many classes do I have to create, and how many objects I need to create out of those objects, and how are those objects going to be interact with each other. And dividing your big problem into those small sections actually has a lot of benefits, and there will be a whole series of videos to talk about that in the future. So let's talk about classes now. Now that we know what is object-oriented programming, and we know what is a class generally and what is objects generally, we're going to talk about the syntax. We already covered what is this encapsulation. So the next, we're basically going to be talking about how do we create classes. Well, there are 2 ways or 2 methods to create classes. We can put our class or classes that we're going to create in a single file, or we can put them in multiple files. Now, at this level, since everything is new to us, I will keep it simple and we'll just put it in a single file. maybe later in the future, where we go back and talk about classes, I'll show you how to create classes using multiple files. It's highly recommended to have every single class in a separated file, which basically is going to make it a lot easier to organize. But again, for now, we're just trying to learn, so we're going to go with the simplest way, which basically you put everything in a single file. Now, the idea or the syntax to create a class basically is very simple. All you have to do is type the keyword class and decide what will be the name of that class. So I'm going to go with student. Now you can see I decided to go with uppercase letters. That's recommended also. But if you want to go with lowercases, it's up to you. Now, Visual Studio will basically add the curly brace, the closed curly brace, and the semicolon at the end. And this will be a class. Now, as you can see here, this is again the head of the class, where basically you define the class and you declare the name of the class, and then this will be the body of the class. Inside the body of the class, elements that you're going to type are organized mainly into basically they have multiple areas or multiple categories of members. We call them specifiers, but at this moment, again, since this isn't new to us, we're just going to talk about two of them. The first area or specifier, that's the right term, is called private. So you type the keyword private and you put a colon and you go down, and then after that you type public and you put colon and you go down. So basically the class is going to be divided into those two main areas. Now I'm going to talk about what is public and what is private in a sec, but let's just focus on the syntax right now. If you decided to take the keyword private away, what's going to happen basically, everything you declare or define at the top of the class here is going to be defined as private by default, and everything under the keyword public is going to be public. If you take them both out, then everything's going to be private. What I'm trying to say here, basically, if you don't specify what is the type of the member that you're going to create, and by member I mean a function or a method or a data, a variable, if you don't specify is it going to be private or public, then by default it's going to be private. But again, I don't want you to leave it to people to guess, especially at the beginning, so type those keywords. Now, at this moment, since we have no idea what is a private, what is a public, I just want to put some rules that you have to follow, and then later we're going to explain why we are following these rules. All of your variables should be declared as private. And not all the method, but most of the methods that we're going to use are going to be declared as public. So as a starting point, let's just put it this way. I'm going to put everything as private if it's a variable, and I'm going to put everything as public if it's a method. Is that the rule? No, it's not. But since this is you're beginning, you're trying to learn, we'll just go for that. And then after, I'm going to explain why do we have private, why do we have public, and then you will find out how to decide if you want to go private or public for your variables. So let's go back to the student. Since I'm creating a class, let's go ahead and add more details. So the student will have a full name, so just like we did before, string, full name. I'll go with an integer, ID. Let's go with another string. Let's put an address. Let's see what else I can put here. Since this is the beginning, I don't want to get into a little bit of detail. I'm going to imagine that this student will have a GPA that will present his overall progress here. Oh, wait a minute. Program, string, lowercase s, of course, program. We're going to specify what kind of program he's enrolled in. And I will create a double, I'll call it G, what is it called? Not GPS, no. Grade. Total grade. I just forgot what they call it. GG something. Anyway. So, I'm going to, the grade here basically is going to be out of 4, so it could be 4 point something something. Anyway, those are the variables that I declared to define a student, and all of these elements are private. What is a private? I'm going to explain it later. Now, for the public side, well, let's just go ahead and create that function that I was talking about, which is the print method. So since I'm creating a method, I'll go void. It's not returning anything, and I'll just say print. Now, print stu. Let's just put it that way, just like we did before. Now, I want you to pay attention to what I'm doing here. I don't need actually to put anything here, and I'm going to explain why. Previously, you saw that I passed the arguments that I used to print the information. And in this case, I don't need to do that. There's a reason for that. But let's just again, I'm going to show you two ways. How do we create methods inside a class? The first one, where you declare the class and you put the implementation in the same space. So as you can see here, I got the method, I got the curly brace, I got the closing curly brace, and that's basically how we create a method. Or if you don't want to do it this way, you can put a semicolon here, which basically will make this one a prototype, and then you copy it, and you can go at the bottom of the main function. You can come here, which basically I will just do it here. Open the curly brace and close. Now, the problem with this technique that I just did here, if I keep it this way, this print student method is not this print student method, because this one is declared inside the class, this is outside of the class, so we need to tell the compiler that this print method is the same as this one. To do that, you need to come here at between the return data type and the name of the class and the name of the method, and you copy the name of the class, and you put it here. And most of, not here, here, and you put colon, a double colon. And now this is basically mean you're telling the compiler that this print student belongs to the class student. Now you can come here and do the implementation. Cout. And I want you to pay attention to something here. I am not passing anything here, as you can see. There's no argument. But yet, I will be able to have access to all of those variables. I can come here and say full name with no problems, end line, semicolon, and then another cout. I'll put ID, end line, and then after that I would go with the cout address, end line. Then after that cout, you know what? I'm going to take this away. That doesn't make a lot of sense. And then I'll just put program and line semicolon. So this is the method that I have here. Now, again, there are a lot of details that you have to pay special attention to. So let me just start all over. I created the class by typing the keyword class, and then I create the name of the class, which is student in this case. This is the beginning, this is the end. Remember, there should be a semicolon here. Visual Studio will add it. If you're not using Visual Studio properly, it will not add it automatically, so you have to pay attention to that. You divide your class area into two main areas here. We got private, we have public. I'm going to explain what is a private or a public, but if you want to have some rules, all the variables must be declared as private, and there's a reason for that. And most of the methods are going to be public. Now, when it comes to the method, we have two ways to define and create the method. You can actually have it underneath or outside of the class, but you just have to remember that you're going to type student, name of the class, colon, and the name of the method. And of course, you have to put the return data type at the beginning of it. And the other thing that you may notice here, that I don't pass any argument, but yet I do have access to all of these variables which are declared inside the class. There's a reason, there's an explanation for all of that. Okay, now let's try to understand, before we start to try to understand the private and public section, we have a special methods that you need to type and you need to include in your class, and we call them constructors. Now remember this word clearly, constructors. Now, what is a constructor? A constructor is a special method that has some properties. Number one, it doesn't have a return data type. Even void, you don't type void. It doesn't have a return type. You see this print stu here? It has a return type. It's void. The constructor doesn't have a return type, so that would be number one. Number two, it must be public. You cannot have it as private. You have to have it as public, otherwise it's going to be useless. And it has the same name as the class. So I'm going to copy the name of the class and I put it here. And then you open the parenthesis and you close it. And I'll put a semicolon here. Okay, so this is a constructor. Now the question that you have to ask yourself, what is a constructor? A constructor, it's a function or a method that would automatically execute it whenever you create an object of that class. So you may ask me, what does that mean? So let me take this away for now. Let me just convert it to a comment because I'm going to go back to it in a sec. Okay, so here we go. This is my class student. This is how I defined the class of student. And this is one of the method implementation, and I'm going to stop at that point. And this is basically, I will consider this as a complete class. Now the question is, how do I create objects out of this class? Well, we come here inside the main function and we do the following. This is extremely important. You go here and you type the name of the class again. And what do you want to call it? Well, I'm going to call it Adam 11. For example, I like to call that object Adam 11. As you can see here, now I have a variable, a user-defined data type, which basically I am the one who decided what is Adam 11. Let me come here and create another one, student. This time I'm going to call it Ahmed 79. Here we go. That's another student. So we do have two objects. This is the first object. This is what I called it. This is the second object. This is what I call it. Both of these objects belong to the same class, which is a student. So I have a student here and I have a student here. Each one of those students has a full name, has an ID, has an address, has a program that he is enrolled in. Now, when I created those two students, what are those values? Well, I didn't decide yet what are these values. So what's going to happen, the compiler will decide to randomly select values and assign it to them. And they will be really, really weird values. Now, how do I see those values? Well, since I have a print method to show you the information, here's what we're going to do. This is extremely important. I will type the name of the object, which is Adam 11, dot, remember, period, print, stu, open a parenthesis and close it. And now I'll do the same thing for the other one, which is item 79. Should be a lowercase a, just what you know, dot, again, print, stu. Okay, it's basically this here. I created those objects. Each one of them has those four variables, but none of those variables actually have a value. So when I try to print them here, the compiler would just choose a random value to show it on the screen. That would be number one. Number two, I don't have to tell, for example, we just say here, Adam 11 print status basically means print all the information that belong to that object, which is Adam. And the same thing here for Ahmed. So let me run it to show you what we're going to get. Of course. And look at them. Those are actually the values. So there's no full name. This is the ID. And there's no address and there's no program. And then there is no full name. And this is the ID. And there's no program and there's no address. So those are the default values that actually the C++ compiler decided to assign to them. Now the question is, well, I don't like that. I want to give them values. Well, this is where the constructor will be used. So let's go ahead and create this constructor. Now, a constructor, basically, we have multiple different types of constructors. We have the default constructor, as you can see here. And let's go ahead and define the default constructor in this area, just to show you that we have those different ways to define a function. So in this area, I'm going to come here and define what is the full name and what is the ID and what are these values for each one of those objects. So the full name is going to equal something, and the ID is going to equal something, and the address is going to equal something, and then we have the program is going to equal something. Now the question is, what is that something? Well, let's talk about the default constructor so we can actually understand what's the other type of constructors. Default constructors is basically called and executed when you create an object and you have no clue what are the values that's supposed to be assigned to a full name or ID or an address. So we basically go ahead and give it a default values. So what is the full name? Well, since I don't know it, I'll just type unknown. And what is the ID? Since I don't know it, I'll give him a default ID, which is basically 100. That's my default ID value. What is the address? Well, we'll just put USA. That's all we know. And what is the program? Unknown as well. So let's go ahead and try to run this program again. As you can see here, I declared Adam and I declared Ahmed, but I didn't decide any of those values for them. So since I didn't decide what would be the value for these two objects, then we'll go with the default values, which basically Adam 11 will have unknown name, an ID of 100, an address of USA, and a program of unknown, and that will be again applied to the second object, which is Ahmed 79. And here we go. You can see that they are exactly the same. Why is this important? Yeah, the default constructor is important. Let's say, for example, you do have a business and you know that you're going to get a call from a customer, but you have no idea or you have no information about that customer. So what do? You create an object for that customer, and then you set everything to be unknown, just like the one that I do. And later on, I will show you how do I change all these default values. But let's just go ahead and say, well, instead of me creating an object where I have no clue about anything, let's say we do have information. For example, let's go to Adam. I know information about Adam. So here's what we do. We open a parenthesis and we close it here. What do we know about Adam? Well, let's say his full name is Adam Smith. The ID that we decided to assign to him is 1, 2, 3, 4, 5. And he is, where does he live? He lives in Overland Park, Kansas, USA. Why is he complaining about Adam Smith? Okay, we'll see. I understand. I'll fix that in a sec. And his degree is in computer science. Okay, now since I'm passing those information, I have his name, I have his ID, I have his address, and I have the program he's enrolled in. I need to have another constructor. Instead of assigning everything to default, I actually will use these information to assign them to that object. So we come here and do a student again. That's another constructor. Remember, no return data type public has the same name as the class. You open the parentheses and close it. And in this area, basically, whatever you're going to pass from here, you're going to receive it here. So you will have a string. I'll go full name, FN. I'm going to show you, this is acceptable right now, but later on we have to change it. And I'm going to show you how. So we got the full name. We have integer for the ID. We'll just put it uppercase IDs, so you will distinguish it between this ID and this ID. And then we have another string. We'll call it address. Again, we'll just put it as address. And then I will have another string, prog. Now, just like we did here, we assigned those unknowns to those variables. And instead of unknown, well, whatever the fn is, it will be assigned to the full name. And whatever the ID that we pass here will be assigned to that ID. Now this is important. I'm going to explain it once I'm done typing everything. And this is going to be ADR, ADDR, and there's going to be prog. Okay, now let's go ahead and give this a try, and you will notice that Adam basically will not have the default values anymore. He basically will have whatever you passed to that object. Let's run it. Adam Smith. This is ID number, this is address, and then here's a computer science student. And then, of course, for Ahmed, there's no information. Okay. Now, let's go back and talk about this constructor. This is what we call an argument constructor. And this is what we call a default constructor. Now, what's the difference between them? A default constructor basically will set all the data members automatically when you create an object, like I did here, to those default values. So when you create an object and you don't follow it with an open and close parentheses, basically you're telling the compiler, go ahead and use the default values to decide what will be assigned to Ahmed, to the full name, ID, address, and program. But when you actually pass arguments, like we did here, this is what we call an argument constructor. The values you're going to pass here will be stored in those arguments, and then they were going to be used to be assigned to those variables. And that's basically what we have here. Now there's a third constructor. It's called the copy constructor. I don't know if we need to talk about it right now. We'll just leave it at this moment. If you want to do a research, it's a very simple copy constructor. But this, I don't want to get into the object-oriented programming details because this is going to be a really long class of a video if I do that. Let's just keep it as simple as those two constructors. Now, there is another important function. It's called the destructure. Now, the destructure basically is very similar to the constructor, and this is it. Now, you may ask me, what is this destructure? Well, number one, it starts with this simple here. I really don't know what it's called. And then you have the name of the class, no arguments, just empty parentheses and empty curly braces. Now, you may ask, what is the deal of this? Now, let me just put it this way. If you forget it, the compiler or the program will work just fine. But there's something happening inside your computer system that you are not aware of, and this is basically against optimization. When you create a program at a certain point in your life, you need to optimize your program. Optimize your program basically means make it run the fastest as possible and use the most efficient way to consume sources. Now, whenever you create an object, let's talk about those two objects, Adam and Ahmed. Though each one of those objects will reserve a space inside the memory. Now, in C++, if you don't have a destructure, that reserved space inside the memory will stay there forever and nobody will be able to use that memory until you shut down your computer system and restart it, which basically means you're wasting the memory. The destructure job is basically has one job, is when the computer program gets to the end of the execution and it's about to terminate, this will act as what we call a garbage collector in Java. Garbage collector basically means, is there any variables that I have? Is there any object that I have in this program that's reserving space? Just wipe everything out. So there will be a fresh new space inside your memory system that could be used by other programs. And that's why we have the destructure. Okay, so we talked about constructors, we talked about destructures, and we talked about the type of constructors. We have the arguments, default arguments. This fact that I have two constructors that share the same name, different types of arguments, this is called overloading constructors. Now, what is the meaning of overloading constructors? As you can see here, I have two objects. I have Adam and I have Ahmed. Now, I want you to guess, since I'm creating those two objects, how can the compiler know which one of them I should call? Should I call this one or should I call this one? Well, the compiler will be able to determine that depending on what he's going to see after the declaration of the object. If I see nothing, then I will go with the default constructor. But if I see a list of arguments, then I'm going to go with the argument constructor. One thing you should know, that the order and the data types are extremely important. If you switch the order, for example, you put the ID here and the full name here, you're going to get errors. They need to match. So since this is a string, it needs to match with a string. Since this is an integer, it needs to match with this integer, and so on. Okay. Now, we talked about constructor, destructures, overloading constructors. I didn't talk about this yet, but that will be the last part of this video. Now, let's go back to this issue here. Now, this will work perfectly fine, but if you're going to go in an interview, they ask you to do this, and you do actually follow whatever I typed here, they will kick you out. Let's just put it that way. So, what is wrong with whatever I did? Well, here is the thing. When you read string fn, I told you right now fn is full name, but if you look at the fn and you have no idea, you started watching the video right now and you see string fn, how would you know what is an fn? There's no way you can know what is an fn. So what we do, we need to actually give it a name that represents what it is. So it's full name. As you can see, that makes more sense than fn. Now, since it's a full name, I need to copy it, and I'll put it here. And this is basically when your compiler is going to start, scratching his head and start asking this question, which one is which? Basically, you have full name equal full name, and you have a full name as an argument, and you have a full name as a string, as a data member here. So what are you trying? Are you trying to get this to be assigned to this in this statement here? Or are you trying to do the opposite? Are you trying to assign this to this? There's no way you can tell. Full name equal full name. That's an assignment operation. This is where the compiler is going to start, having a headache. So how do you fix this problem? Well, there's a magic solution, and the magic solution is very simple. Now, you need to ask yourself a question. Which one of those two variables belong to the object? I want you to point at one of them and give me the keyword. Basically, you will point to this one, and you're going to come here and type this full name. Oh, sorry, it's not. Yep, again, I teach Java and C++ at the same time, so I get confused between them sometimes. So, when you use this keyword, you're basically telling this full name basically is this one. And the other one is the argument. So what we're going to do, we're going to do the same thing for the rest of them. ID, and I'll just come here and type this ID equal this ID. Of course, I have to put this as a lowercase. And for the address, we'll just do the same thing. And you have to come here and say this address. What are you doing here? Okay. And then program. In program. You come here and type this. Now, the keyword this has a lot of usages in object-oriented programming, but we'll just keep it simple, and this is the only one that I want you to be worried about. So, that's the keyword this. Okay. Now, the last part I want to talk about here is, I didn't mention what is the point of private and what is the point of public. Well, here's the deal. Public elements are accessible anywhere in your project. You may ask the question, what does that mean? You see here when I typed Adam and Ahmed, and I tried to have access to the print STU. What is print STU? Print STU is a method, and it's public. So I have access to it with no problems. But let's look at the private elements. For example, full name. If I come here, and let me try to do it here. I'll say Ahmed 79 dot full name, and I'll just say equal Ahmed Baljanabi. I put a semicolon here. Immediately you get an error. Now I don't know if you can zoom or not, but this is the error saying this variable full name declared in line 18, so you go up and you see it like that, is inaccessible. You don't have access to it. Why do I don't have access to it? Because it's private. So private elements, you cannot have access to them outside of the class. Remember this, you cannot have access to them outside of the class. Main function, it's outside of the class. So you don't have access to it. Well, so how do I have access to it? Well, let me show you something. You see here when I try to print it on the screen, it didn't complain. Why? Because print method belong to the class, and since you belong to the class, you can have access to it. Think about private elements as a luxury that's available for a member of a class only. So since I declared print, and print is a member in that class, it's public, so you can have access to it outside of the class, but at the same time, all these private elements, you can have access to them using the print method. But if you move outside and try to have access to them here, you cannot have direct access to any private members. So that basically will cause a lot of complications because, in a lot of cases, okay, what if I want to change the name of? Let's imagine we got a student and I asked him about his full name on the phone and he gave it to me, and then it turns out that I misspelled it, so I have to change it. Since I only cannot have access to it directly, so how do I change it? Well, to do that, all you have to do, come here and create a new method for each one of them. We'll just go ahead and do this here. I'll say void set full name. And in this area, I'm going to put string full name, semicolon, sorry, not semicolon. And here I'll say this full name equal full name. Okay, so now if I want to change it, I can come here and now and do it. I'll say Ahmed79 dot set full name, and I'll come here and say Ahmed Janabi. Okay, so you can see here it's not it's not having any problems. It can compile with no problems. Let me just run it for you. So you'll see that I was able to change it from unknown to equal whatever I want it to equal. Okay, now I'm sure you have this question in your head and you're asking, well, why do I have to do that? Why don't you just put everything as public and get it over with? Well, object-oriented programming has one concept, which is basically means hide details, hide information. What does that mean? Again, you don't have to know it right now. I'm just going to say it, but again, in the future, there will be more videos, and you will have to enroll in. If you're a computer science student, you'll have to enroll in a class called Object-Oriented Programming. So, in Object-Oriented Programming, you need to create all your data members are private because you want to hide them from anyone inside the main function who would want to go ahead and have access to them and change them. Why do we want to do that? Well, for two reasons. Reason number one, to hide details from the user. You work for a company, you create a class called student, and in this student you have 100,000 different variables and you have 20,000 different methods. If your customer need to understand all these details to be able to use your class, then nobody will buy it. You basically need to simplify it. The way we simplify classes is basically by hiding all the details and keeping everything private, and then just keep one or two methods public for the user, and they're simple and easy, and the user will be able to learn how to use them without the need to get into the details of how do they work. So that'll be reason number one. Reason number two, those values, for example, let's say set full name. Where's set full name? Here is set full name. Let's imagine in my rule at my college that I own, I am not allowed to have a student with the full name Ahmed Al-Janabi. That's it. That's my rule. This is my college. This is my rule. I don't want to have a student with that name. Here, at this place inside the setter, I can set those rules. I can have full control over what kind of values could be assigned to those variables or what values could not be assigned. For example, you're doing something really, really critical, and your calculations basically need to be accurate 100%. Otherwise, let's say the whole manufacturer will be turned down, or the manufacturer is going to be shut down. So you have values, for example, the voltage that's going to be fed to the machines. Well, what if a user decided that that value should be really, really high? And if that's possible, the whole system is going to be shutting down. Well, this is your area where you have control over what kind of values is going to be used. So even if somebody tried to change it, you can stop them at this point by putting an if statement. If the value matches values or greater than this value or less than the value, just avoid it. Don't use it. Give a warning message and kick that person out. So that's why we have those private elements. Now, you may not get the idea 100%, and if you just want to survive, I will again recommend that every time you create a class, put all your data members to be private and your method need to be public. I will stop at this point. This is mostly everything about classes that you need to know, at least at this level. Let me just tell you, classes and Objectoriented program by itself, it's a 6-month class. So it's not this simple, but again, we're just trying to have an idea here. This will be the end of this course, this video, sorry. And I'll see you guys in the next video. Have a good night.